Good day, everyone. Today we will explore the topic mineral and soil resources. These two natural resources are essential to life and development. Minerals are valuable materials found in the earth that are used in construction, technology, and industry. Soil, on the other hand, supports plant growth and is the foundation of our agriculture. However, both resources are limited and can be damaged by human activities. That's why it's important to understand how they are used and how we can protect them for our future generations. Everyone, today we'll briefly talk about economic geology and the economic perspective of minerals. Economic geology is the study of earth materials like minerals that are valuable for economic use, such as metals, fuels, and building materials. Minerals support industries like construction, electronics, energy, and agriculture. They are key to economic development. We classify them into three: the metallic, example, gold or copper. The second one is the non-metallic, like salt and clay. And the third one is energy, for example, coal or oil. Minerals bring income, jobs, and exports, but they must be managed wisely to avoid environmental damage. In short, minerals are valuable resources that power our economy. Responsible use ensures sustainable growth. Thank you for listening.
Good morning once again, everyone. Now, let's talk about how minerals are extracted and processed. Mineral extraction and processing are essential steps in obtaining valuable resources from Earth's crust. The method employed vary depending on the type of mineral, its location, and the desired end product. These processes involve a combination of geological knowledge, engineering expertise, and environmental consideration. Let's talk about how minerals are extracted. And these are the mining methods. The first one is the surface mining. This method is used for shallow deposits where the overburden, rock, and soil covering the mineral deposit is removed to access the ore. The common types include open pit mining. A large open excavation is created to extract the ore. Strip mining, used for minerals found in horizontal layers where the overburden is removed in strips. The next one is quarrying, used for extracting building materials like stone, gravel, and sand. The second type of how minerals are extracted is the underground mining. This method is used for deeper deposit where tunnels and shafts are created to access the ore. The common types include shaft mining. A vertical shaft is sunk to reach the ore body. The next one is the drift mining. Horizontal tunnels are driven into the hillside to access the ore. The last one is the room and pillar mining. Rooms are excavated, leaving pillars of ore to support the roof. Now, let's move on to how minerals are processed. Once the ore is extracted, it undergoes processing to separate the valuable minerals from impurities. And these are the key steps include. The first one is crushing and grinding. The ore is broken down into smaller particles to increase surface area for subsequent processing. The next one is the concentration. Methods like flotation, magnetic separation, and gravity separation are used to concentrate the desired minerals. The third one is leaching. This involves dissolving the desired mineral into a solvent, leaving the impurities behind. The fourth one is smelting. This process involves heating the concentrated ore to high temperature to melt and extract the desired metal. And the last one is refining. The extracted metal is further purified to meet specific quality standards. For the environmental consideration, minerals extraction and processing can have significant environmental impacts, and these include habitat loss and fragmentation. Mining activities can destroy the natural habitats and disrupt ecosystems. The next one is the air and water pollution. Mining operation can release dust, chemicals, and other pollutants into the air and water. And the last one is the land degradation. Mining can leave behind large pitched piles of waste rock and contaminated soil. To mitigate these impacts, sustainable mining practices are increasingly emphasized. The future of mineral extraction and processing, the demand for minerals is expected to grow as the global population and economies expand. To meet this demand sustainably, technological advancement are important. Improve extraction techniques, developing more efficient and less environmentally damaging extraction methods. Number two is resource recovery and recycling. In- Increasing the recycling of valuable minerals from waste streams. The last one is alternative materials. Exploring and developing alternative materials to reduce reliance or scarce or environmentally harmful materials. The responsible extraction and processing of minerals are essential for meeting the needs of a growing global population, while minimizing environmental impacts by embracing sustainable practices and technological innovation. The mining industry can play a vital role in a more sustainable future. And that's it for my part. Thank you so much.
Now, let's proceed to the mining and the environment. Mining is the process of extracting minerals from earth. These minerals are important for our daily needs, like for construction, electronics, and transportation. However, if mining is not done properly, it can cause serious environmental problems. The first one is the deforestation. Deforestation happens when forests are cleared to make way for mining operations. This destroys the natural homes of many animals and plants, which leads to loss of our biodiversity. The second one is the soil erosion. Soil erosion becomes a problem because when trees and plants are removed, the topsoil becomes loose. This makes the land unstable and unfit for farming or other uses. The third one is the water pollution. Water pollution occurs when harmful chemicals such as mercury and cyanide are used to extract minerals. These chemicals can leak into rivers and groundwater, harming aquatic life and possibly affecting human health. Lastly, the air pollution. Air pollution is also a concern. Mining activities create a lot of dust and gas emissions. These pollutants can cause respiratory problems for people living near mining areas and also affect animals and plants. In conclusion, while mining helps grow the economy, it must be done in a responsible and sustainable way to reduce harm to our environment.
Good afternoon, everyone. Let us now move to soil properties and processes. First is the soil formation and soil composition. Soil formation, also known as pedogenesis, a natural process where soil develops from parent material influenced by climate, organisms, topography, and time. On the other hand, soil composition is a mixture of mineral matter, organic matter, water, and air with living organisms also present. As what said, there are five types of soil formation. First is the parent material, the bedrock or unconsolidated material from which soil develops. It means that if the parent material is granite bedrock, a hard, slow withering rock, the soil that develops will likely be sandy and acidic. It may take a very long time to form a deep layer. On the other hand, if the parent material is volcanic ash, which is soft and full of nutrients, the soil that forms could be very fertile and develop relatively quick. Second is the climate. Temperature and moisture influence weathering rates and organic matter. This means that because it's always hot, the rock here break down faster, like how food spoils quicker in the heat. And because it rains a lot, this breakdown happens even faster, washing away bits of rock and helping to create soil. This hot and wet weather, this hot and wet weather also makes lots of plants grow. When these plants die and rot, They become like natural fertilizer, making our soil rich and good for growing more plants. Think of it like adding compost to your garden. It makes the soil healthier. However, all that rain can also be like washing away some of the good stuff from the soil, like when your rains rise too much and some of the nutrients go down the drain. So even though the hot and wet weather helps make soil quickly and adds good stuff from plants, we also need to be mindful that some of the important nutrients can get washed away by the rain. Next is organisms. Plants, animals, and microorganisms contribute to soil structure and nutrient cycling. Think about the trees that are so abundant here. Their extensive root systems, especially those of large dipterocarps or fruit-bearing trees like mango and durian, don't just anchor the trees. They create a network of channels in the soil. These channels improve soil aeration, which allowing air to reach roots, and water infiltration, helping rainwater soak in instead of running off, which is crucial during our heavy rains. When these trees dried their leaves, branches, and eventually die and decompose, they contribute a significant amount of organic matter to the topsoil. This decaying material is a feast for other organisms. Consider also the earthworms, which thrive in our moist tropical soils. You've probably seen them wriggling around. They are like natural tillers, constantly burrowing through the soil, creating pathways for air and water, and improving soil structure. As they ingest soil and organic matter, their castings or worm poops are rich in plant available nutrients, effectively cycling nutrients and making them accessible to plants. Next is topography. Slope, aspect, and elevation affect soil moisture, erosion, and drainage. It means that if the soil is sloped, rainwater rushes down fast, taking soil with it and not soaking in much. If it's a flat part of the playground, water sits longer and can make the ground soggy, while a hill faces the sun or is in the shade, aspect can make it drier or wetter. And being higher up elevation can means it's cooler and gets more rain, affecting the soil. So the shape of the land really changes how wet the soil is, how much washes away, and how well water drains. Last is the time. Soil formation is a slow process that occurs over many years or even centuries. Now let's move to the soil composition. First is the mineral matter. This is the broken down rock fragments, including sand, silt, and clay. It means that taking a big rock and smashing it into tiny pieces, that kind of what happens to create mineral matter in soil. These tiny pieces come in different sizes. Big ones are like sand you see at the beach. Medium ones are called silt, and the smallest one are clay, which feels sticky when wet. These broken down rocks makes up most of the soil and provides the basic building blocks and some of the nutrients that plants needs to grow. Next is the organic matter. Decomposed plants and animal matter, providing nutrients and improving soil structure. It means that organic matter is all the dead leaves, fallen branches, and remains of animals that have broken down. This stuff is like a natural fertilizer full of good food nutrients that plants needs to grow strong. It also helps the soil stay loose and holds onto water better, kinds of like adding sponges to the soil. Next is water, essential for nutrient transport, plant growth, and microbial activity. Water is the soil is likely delivery truck and a kitchen for plants and creatures. It carries the foods from the soil to the plant roots so they can grow. Also, just like we need water to live, tiny bugs in the soil needs it to do their jobs like breaking down old plant stuff. So water is super important for keeping everything in the soil alive and working properly. Next is air. It occupies pore spaces in soil, providing oxygen for roots, respiration, and microbial activities. It means that think of soil having tiny little holes, like a sponge. These holes aren't just for water, they also hold air. Plant roots needs to breathe, just like we do, and they get the oxygen they need from this air in the soil. Also, those tiny helpful bugs in the soil needs air to live and do their job of breaking down stuff and keeping the soil healthy. So, air in the soil is just as important as water for things to grow and thrive. Last is the living organisms. Microbes, earthworms, and other organisms contribute to nutrient cycling and soil health. That's all for my part. Thank you.
Good afternoon, everyone. So, for the continuation of our topic, we are now going to the soil organisms. So, there are 5 types of soil organisms that I am going to share with you today. The first one is microbes, next is microfauna, and then mesofauna, the macrofauna, and the megafauna. Before I will present the 5 types of soil organisms, let's go first to what is soil organism. Soil organisms are any living creatures that inhabit the soil, playing crucial roles in maintaining soil health and fertility. They range in size from microscopic bacteria to larger animals like earthworms and moss. Their activity influences soil structure, drainage, aeration, and nutrient cycling. So now let's move to the first soil organism, which is the microbes. Microbes are microscopic organisms too small to be seen without microscope. They encompass a vast range of life form, including bacteria, archaea, fungi, protists, and viruses. Some microbes are beneficial, aiding digestion or producing food like yogurt. Others are harmful, causing diseases like influenza or tuberculosis. So here is an example image of a microbes. The second type of soil organism is the microfauna. It is the smallest animal, generally less than 100 micrometers in size. Examples include protozoa, nematodes, and rotifers. They are important decomposers and play a role in nutrient cycling. Then here are the examples of microfauna. The third one is the mesofauna. Small animals, including mites and springtails, they enhance soil aeration and decomposition. Their feeding activities mix organic and mineral components within the soil. Now, here are the examples of mesofauna. The fourth one is the macrofauna. It is larger animals, such as earthworms, snails, and insects. They create burrows and channels, improving soil aeration and water infiltration. Their feeding and improvement mix soil layers and redistribute nutrients. Here is the sample photo of macrofauna. So the last type of the soil organisms is megafauna. It is the largest soil animals, such as moles, gophers, and rabbits. Their burrowing activity significantly alters soil structure, creating pathways for water and air. Their feeding modifies vegetation patterns, influencing soil composition. Here are samples of megafauna. We should also remember the functions of the 5 types of soil organisms. The first one is the decomposition. They break down organic matter, releasing nutrients for plants. Second is the nutrient cycling. They participate in crucial nutrient cycles like nitrogen, phosphorus, etc., making nutrients available to plants. Third is the soil structure improvement. Their activities improve soil aeration, water infiltration, and drainage. The fourth one is disease suppression. Some organisms suppress plant diseases and control pests. The last function is the symbiotic relationships. Many organisms form mutually beneficial relationships with plants.
Soil erosion. Soil erosion refers to the erosion of the top layer of dirt known as topsoil, the fertile material vital to life. The rate of soil erosion depends on many factors, including the soil's makeup, vegetation, and the intensity of wind and rain. Because of people's activities, it also can influence the speed of soil erosion. We, people, have the power and the responsibility to solve one of the planet's greatest environmental challenges. So, soil erosion is when the topsoil gets washed or blown away. This happens when the ground is bare or don't have any plants, and also if it is exposed to strong winds and heavy rains. For example, in farming, if they plowing fields and deforestation like cutting down trees make it worse. Even climate change with its unpredictable weather makes soil erosion a bigger problem. So severe soil erosion can result to the top loss of food crops, negatively impact community resiliency and livelihoods, and even the ecosystems by reducing biodiversity above, within, and below the topsoil.
Soil pollution. Soil pollution happens when harmful substances build up in a soil, affecting plant growth, animal health, human health, and the ecosystem. These harmful substances can come from various sources. Agricultural chemicals. Using too many pesticides and synthetic fertilizers can lead to their buildup in the soil. Pesticides can harm non-target organisms and disrupt soil life. Fertilizers can wash into groundwater, causing water pollution and making the soil more acidic. Heavy metals. Activities like mining and manufacturing can release heavy metals such as lead, mercury, cadmium, and arsenic into the soil. These metals can stay in the environment for a long time, accumulate in food, and pose health risks to humans and animals. Industrial waste. Poor disposal of industrial waste, including chemicals and sludges, can contaminate the soil with dangerous substances. Petroleum hydrocarbons. Oil leaks and spills can introduce harmful hydrocarbons into the soil, which can be toxic to plants and microorganisms and can persist for years. Sewage sludge and wastewater. Well treated sewage sludge can improve soil, untreated sludge and wastewater can introduce germs, heavy metals, and other pollutants. Landfills. Pollutants from landfills can seep into the soil and groundwater if not managed properly. Atmospheric deposition. Air pollution from factories and vehicles can settle on the soil through rain or dust, leading to soil acidification and heavy metal contamination. Effects of soil pollution. Reduce plant growth and crop yield. Pollutants can harm plant growth, reduce nutrient absorption, and make plants more vulnerable to diseases, decreasing agricultural production. Contamination of the food chain. Pollutants can be absorbed by plants and enter the food chain when animals and humans eat them, causing health issues. Threats to human health. Touching contaminated soil, eating polluted foods, or drinking dirty water, and breathing in dust can lead to serious health problems, including neurological issues and cancer. Harm to soil life and ecosystem function. Soil pollution can disrupt important soil life and harm helpful organisms like earthworms, affecting processes like nutrient cycling and soil structure. And lastly, water pollution. Pollutants in the soil can wash into groundwater or surface water, harming water resources and aquatic life.
Soil conservation and regeneration. Soil conservation and regeneration are essential strategies for maintaining and improving the health and productivity of soil. Soil conservation focuses on protecting soil from degradation and erosion, while soil regeneration involves restoring damaged or depleted soils to enhance their functionality. Together, these practices support sustainable agriculture, improve food security, and contribute to overall ecosystem health. Next slide. Soil conservation refers to a variety of farming methods designed to prevent soil degradation, erosion, and nutrient depletion. These practices ensure that soil remains healthy and capable of supporting crops over long term. In contrast, soil regeneration focuses on rehabilitating soils that have already been degraded. This includes improving the soil's physical structure, chemical composition, and biological activity to support plant growth and restore ecosystem function. Next slide. These are the objectives of soil conservation. It maintains soil health and long-term fertility, preventing soil erosion and protecting water quality in nearby rivers and lakes. It reducing dependence on synthetic fertilizers and pesticides, supporting biodiversity and other ecosystem services such as pollination and carbon storage. An example of soil conservation practice. Two effective methods used in soil conservation are reduced tillage or no-till farming. These practices involves limiting soil disturbance which helps to prevent erosion, maintain soil structure, and reduce the loss of nutrients. The second example are cover cropping. Planting crops like clover between main crop seasons protect the soil surface, adds organic matter, and improves soil fertility. Now let's move in soil regeneration. The objectives of soil regeneration is to restore and rehabilitate soils that have been degraded, increase the organic matter content and improve soil structure, reintroduce biodiversity and strengthen ecosystem services, promote better water infiltration and more efficient nutrient cycling, build resilience against climate change and extreme weather events. Examples of soil regeneration practice is restoration of degraded lands. This involves reforesting barren lands, planting vegetation, and applying soil remediation techniques to bring soil back to productive use. Second is use of cover crops and green manures. These are crops planted primarily to improve soil quality rather than for harvest. They keep out organic matter, reduce weed growth, and enhance soil structure. So that's it. That's the part of the soil conservation and regeneration. Thank you for listening.